Welcome to Brain Vision.
So in order to find the percentage of the artery that is blocked by plaque, we need to use Bernoulli's equation. So Bernoulli's equation simply states that the pressure in one section times half of the density times the velocity squared plus the density times the Earth's gravity times the height, or rather the height of the artery, is going to equal some constant c. One can say that this side of the equation can be considered the artery that is not blocked by plaque, and then we can define some second section of the artery, p sub 2 plus half v sub 2 squared plus, again, density, gravitational, h sub 2. Now, the actual dimensions of the artery do not change. So here, H1 is actually equal to H2 because although the artery is being blocked by plaque, the actual dimensions of the artery do not change. So here, this and this are going to be canceled out. After this, we can solve for V2 because V2 is what we want to find in order to get to the equation of continuity. So at this point, we can isolate this V2 here, and we can say that V sub 2, the velocity in the second section of the artery where it is blocked by plaque, is going to equal the square root of 2 times p sub 1 minus p sub 2 divided by the density of blood plus the velocity in the first section of the artery. So we have all of these constants. The density of the blood is simply going to be equal to that person's specific gravity times the density of water. And this is simply going to be equal to 1.06 times 1,000 kilograms per meters cubed. And the density of this person's blood specifically is going to be 1,060 kilograms per meters cubed. P sub 1 equals 1.20 times 10 to the 4th pascals. P sub 2 equals 1.15 times 10 to the 4th pascals. And then we have the velocity in the first section of the artery that is not blocked by plaque of 30.0 centimeters per second, or 0.30 meters per second. We need everything in meters, pascals. We need everything in SI units. So solving for this, we have the square root of 2 times, and then here we're going to say, we can actually take away scientific notation just because it might be a little bit easier to solve. Here it would just be simply 12,000 minus 11,500 divided by the density of blood, 1060, plus the velocity in the first section of the artery squared. So here we find that the velocity in the second section of the artery is going to be 1.0166 meters per second. Now, as you can see, the cross-sectional area has obviously decreased because the velocity has increased, and we can see this in the equation of continuity. So the equation of continuity says that the cross-sectional area of the first section times the velocity in the first section is going to equal the cross-sectional area of the section that is blocked by plaque times the velocity of the second section. And here we're going to make a relationship and say that a sub 2 over a sub 1 equals v sub 1 over v sub 2. At this point, we can actually solve for our the percentage that is blocked by plaq. So here, actually, we can say that the percentage that is blocked by plaq can be defined as a sub 1 minus a sub 2 divided by a sub 1 times 100%. So here we're taking the original cross-sectional area, subtracting the cross-sectional area of the second section of the artery, dividing it by the original cross-sectional area, and we'll find a percentage of the artery that is blocked by plaq. Solving for this, we can rewrite this and say that the percentage blocked by plaq is going to be 1 minus a sub 2 over a sub 1 times 100%. And then we can furthermore solve for this and say that 1 minus v sub 1 over v sub 2 times 100% will give us our percentage blocked by plaq. This is going to be 1 minus, so the velocity in the first section is going to be 0.3 meters per second, and then the velocity in the second section we found to be 1.0166 meters per second. Again, times 100%. So the percentage blocked by plaq is going to equal 70%, approximately. So we needed Bernoulli's equation in order to solve for the velocity in the second section of the pipe. At this point, we can then use the equation of continuity in order to find a relative, in order to find the difference, rather the ratio of the cross-sectional area of the second section compared to the cross-sectional area of the first section. And then we set up an equation here in order to find the percentage that is blocked by plaq, substituting in for our velocities. And again, the percentage blocked by plaq is going to be 70% here. And that's the end of the solution. Thank you for watching.